In lesson 51, we're going to talk about imaginary numbers. Now, whenever people hear imaginary numbers, that is intimidating, and it doesn't need to be because they're really not too difficult. Just to progress to what an imaginary number is, if you have square root of 4, we know that that's 2. If you have negative outside of the square root of 4, that's negative 2. So these can actually be graphed on a number line. Right here we have negative square root of 4, aka negative 2, and square root of 4, aka 2. But what if we had a square root of negative 4? Well, if you actually put that in your calculator and said square root of negative 4, it would say error, non-real answer, aka it's an imaginary number. So what we do to solve for these, well, let me say this. We use the letter I. Now, what I stands for is imaginary number, and what I technically means is square root of negative 1, because this isn't an imaginary number, meaning it cannot be found on a linear graph. So if I is square root of negative 1, what that means is square root of negative 1, square root of negative 1, aka I times I equals negative 1. And this is known as our wheel of i's here. So I cubed would be negative I, and then I to the 4th would equal 1. Now let's look at example 51, 2. It says, translate these to imaginary numbers. Or sorry, it says in 51.2, you use Euler's notation. This is referred to as Euler's notation. It says use Euler's notation to rewrite these numbers. So if you have a negative inside of a square root, what we're going to do is leave the number inside the square root, and then we are going to take the negative and turn that into an I. And that would be how we write it. That's all you do. And that's the same as saying square root of 13 times square root of negative 1. We are just substituting I in for negative 1. So this would be how we want to write it. Say you have square root of negative 4. Well, we take the square root, or we take the negative out, and are left with square root of 4. Well, we actually know what the square root of 4 is. The square root of 4 is 2. So we call it 2I. We leave the I. And then the last one is square root of 3 times negative square root of 2. Just like if we had square root of 3 times square root of 2, it would be square root of 6. Except you take the negative out, it would be square root of 6I. So that's just a brief intro into imaginary numbers. Example 51.3 says, what if you have all of these? And it says to add them. Well, all you have to do is treat these like they're like terms, just like we've done with the variable x or whatever other variable. They're like terms. So therefore, we can add 4 minus 2, that's 2, and 6i plus 3i, being positive 9i, and that would be your answer. That's all you do. Now, one thing to note is you always want the whole number in front of the imaginary number. We do not want to write 9i plus 2. That's bad. We want to keep the whole number in front. That's just how these complex numbers are written. In 51.4, we have all this, and it wants us to add it together. Well, we can actually go ahead and eliminate the parentheses because nothing else is being multiplied. So those are unnecessary. And then all we do is combine like numbers like we did before. 4 and 6 is 10. 10 minus 2 is 8. So we got those. Negative 3i minus 4i is negative 7i minus 5i, negative 12i. There's your answer. Now let's look at a couple problems using our wheel of i's that we have. Now, like I said, if we have I, that's negative, or square root of negative 1, I squared is negative 1, I cubed is negative I, and then I to the fourth is positive 1. Because, so why it's 1 is because if you had negative 1 times negative 1, like so, that would equal a positive 1. So that's why it is like that. Now let's look at what we have here. It says 2i squared minus 3i cubed, all that. 2i squared. So let's look at this I squared. Well, what did we say I squared was here? We said that's negative 1. So we're going to substitute negative 1 in for I squared. Moving here, minus 3. What did we say I cubed is? We said that's negative I. So if we wrote that, that would be the same as saying positive 3i when we multiply it. Let's go ahead and multiply this. 2 times negative 1, negative 2, negative 3, negative I is positive 3i. Then we have plus 2i, can't do anything there. Minus 4. Then it says minus square root of negative 4. Let's look at that individually. Well, take the negative out to make it an I. And then the square root of 4 is 2. So that becomes 2i. Like so. And then we are able to add it. Negative 2 minus 4 is negative 6. 3i plus 2i is 5i minus 2, 3i. There would be your answer. Negative 6 minus 3i. This says plus 3i. My bad, plus 3i. 51.6, same one. Now it just writes it instead of I, it's saying I cubed. And this is probably going to be most like how you see it. So 3i cubed is negative I, so 3 times negative I, and you'll be able to get to the point where you just write negative 3i, but plus 2i squared, okay, I squared is negative 1, so plus 2 times negative 1, plus 7i, plus 4. Okay, then we have plus 2i to the fifth. That's not on here. Well, what you can do is, okay, we have I to the fifth. If I showed you this way, you should understand it. We have 5 i's, since it's I to the fifth. Well, we said 4 i's equals to 1. So basically, I can cross out 4 of those i's and be left with just 1 I. So I to the fifth, we could say, is I. It would go in an endless cycle. I to the sixth would be negative 1. I to the seventh would be negative I, and so on and so forth. So therefore, this would become 2I. And now we can multiply negative 3I minus 2 plus 7I. And now we can add like terms. Negative 3i, 7i is 4i, plus 2i is 6i. Negative 2 plus 4 is 2. So you get 2 plus 6i. And that is how you do imaginary numbers.